All right, here in this last video in section 12.1, we're going to look at question number 4 in the worksheet. This says to consider the rational function f of x is equal to 3x divided by x minus 4. And part A is asking what happens to f of x as x becomes infinitely large, i.e. as we let x approach infinity. Okay, so we can solve this by just thinking about plugging in some really big values of x and then just seeing what's going on with our outputs. Okay, so I'll go ahead and plug in to start, say x is equal to 100. Okay, if you do that, you wind up getting 3.125 or 3 and an eighth. So I'm just going to set 100 in for x up here, so I'd get 300 in the top, and then down here I'm going to get 100 minus 4, that'd be 96. 300 divided by 96 is your 3.125. Okay, now if I go ahead and plug in, say, 1,000, okay, this turns out to be kind of a messy number, but it's about 3.0120,482. Okay, so, just a little bit above 3. If I did, say, 10,000 for x, so getting even bigger, the y value there, the output, would be 3.0012005. Okay, so still a little bit bigger than 3, but even closer to 3 now than what we saw with just 1,000, right? If I plug in 100,000, so just keep tacking on a 0 for x, here you get roughly, rounding a little bit, 3.00012. Okay, now if I continue to just make x larger and larger, so in other words, I'm going to let x become infinitely big, what I'm seeing with the y output values is that these things are getting closer and closer to 3. Okay, so here's what we can say for our answer to part A. We can say our function output, f of x, this thing is approaching 3 as we let x become infinitely large. So this is just a shorthand way to express the fact that the y value outputs are all getting closer and closer to 3 as we let x get larger and larger. Okay. Now for part B, it says what happens to f of x as x approaches 4. Well, we're going to just, again, plug in some values here for x. And first I'll plug in some values that are just slightly smaller than 4. Like let's say 3.9. Okay, if you do that, you wind up getting minus 117. If you plug in, say, 3.99, you wind up getting minus 1,197. If you plug in, say, 3.999, so I'm just inching closer and closer to 4 from the left, here I'd get minus 11,997. Okay, and so on and so forth. So if I keep, say, tacking on a 9 here for the x value, I can see that the output y values for f of x are getting, well, infinitely big now, but they're also negative. Okay, so let's keep that in mind. I next want to go ahead and look at some values that are close to 4 but just slightly larger, like let's say 4.1. If I plug that in, I wind up getting actually a positive number. It's 123. If you plug in 4.01, you wind up getting 1203. So 1,203. Put another 0 in there, so 4.001, I'm going to get a whopping 12,003. You can see this pattern starting to emerge. Here I'm seeing that as I inch closer and closer to 4 now from the right, then the y values are becoming infinitely large but positive. Okay, so here's how we can summarize that. We could say that when x, here actually I'll phrase it this way, I'll say f of x, the output values, these things are becoming what? Infinitely big and negative. So these are, I'm going to write this as approaching negative infinity as x approaches 4, but just to emphasize, right, that it's 4 from the left, I'm going to put a little minus sign up here just to say, hey, like, think about numbers just shy of 4. So just slightly smaller, like 3.999, for example. So that's what's going on from the left. And then from the right now we're seeing our function values, the y outputs, becoming infinitely big. So I'd say these things are becoming infinitely big as we let x approach, and here be 4 from the right. These are all numbers for x that are just slightly more than 4, 4.001, 4.0001, so on and so forth. Okay, so this would be a way to write that conclusion here. All right, great. So that does it for this problem. The last thing I will say real quick is just let's check out a graph just to get kind of a feel for the results we just found. So I have here is a graph of my function. And like what we saw in the very first question, right, we had one of these, what we call the vertical asymptote at 4, okay? And notice here, if we're really close to 4, but just from the right, what's going on with the y values, right? If I zoom out, the y values are becoming infinitely large and positive. That's exactly what we said here, right, in blue. The y values become infinitely large as x becomes closer and closer to 4 from the right. Cool. All right, so then what about on the other side? Well, now these things, right, are becoming closer and closer to 4 from the left, and our y values are becoming infinitely big and negative, right? So that's what we were saying here in green. Okay, cool. So then what about the part A result, right? That the y values were getting close to 3 as we let x become infinitely big. I'll put this line in here. Notice here if I go way out to the right, so x now is becoming infinitely big. What's going on with y? You can see here is y is equal to 3, right between 2 and 4. And our graph in blue is becoming infinitely close to this green horizontal line at y is equal to 3. Okay, so we're approaching that horizontal line now, making x big. We'd call that green line a horizontal asymptote. We use that same term in the first question. All right, cool. Well, that's going to do it for this problem and for section 12.1. We're going to start 12.2 in the next series of videos. All right, see you there.